This channel has been created for GCE O Level students. However, the students of other educational systems can avail of it. I upload video lessons twice a week. Subscribe my channel now. Thanks. Vectors. The quantities which have both magnitude and direction are called vector quantities. That's why these are called directional quantities. Examples: when a ship sails 8 kilometers from P to Q on a bearing of 0.75 degrees, then this displacement is a vector quantity. It comprises of two things: a displacement of 8 kilometers, this is the magnitude, and bearing of 0.75 degrees from P to Q is the direction. That's why it is a directional quantity. The second example: the plane is flying due north at 750 kilometers per hour. Here, 750 kilometers per hour is the magnitude and due north is the direction. So this is also an example of a vector quantity. The third one: move the desk 5 meters to the right. 5 meters is the magnitude, to the right is the direction. So in all of the three examples we see that magnitude as well as direction are mentioned, and that's why all these three examples show vector quantities. In fact, vector quantities are those quantities which are directional. The displacement of 8 kilometers from P to Q is represented by a straight line PQ. This is PQ. PQ line, this one. So 8 kilometers displacement. Second example is for the velocity of 750 kilometers per hour due north, and it has been mentioned with the help of this vector, this reddish vector. In the case of displacing a desk from left to right, we move it 5 meters from left to right. We mention left side, right side, and this is the displacement. This movement is in some specific direction, and this specific direction is from left to right. In simple diagrams, we can represent the displacement PQ 8 kilometers from P to Q. In simple diagram, we can represent the displacement from P to Q, that is of 8 kilometers, and we have to put an arrow. This arrow indicates the direction from P to Q. Similarly, the velocity of 750 kilometers per hour has been represented by the vector AB, and arrow shows the direction from A to B, and it is parallel to north. That's why the direction of the velocity is due north. This is the third example: the movement of the desk from left to right. it has been mentioned by the vector xy. So we move the dex 5 meters from x to y. Again the arrow is indicating the direction of the motion. Representation of a vector and notation. A vector quantity can be represented by a directed line segment whose direction is that of the vector and whose length represents the magnitude of the vector. For example, the displacement of the ship from P to Q is represented by the directed line segment PQ, that's of 8 kilometers. So length of PQ indicates the magnitude and the arrow indicates the direction of the vector. So PQ is a vector of 8 kilometers. Similarly, the velocity of the plane is denoted by AB vector and represented by the directed line segment as shown in the above figure. The translation of the disk is denoted by XY and represented by the directed line segment as shown in the figure. Its length is 5 meters. It is the magnitude, and the arrow indicates that the vector starts from X and terminates at Y. The vector PQ shown in the figure has length PQ and direction given by the arrow from P to Q. In the notation PQ, the order of the letters is important. It indicates the sense of direction of PQ. P is called the initial point and Q is the terminal point of PQ. The vector PQ is represented by PQ with an arrow over it. However, in order to show the magnitude of the vector PQ, we simply write down PQ and there is no arrow at all.